Okay, so let's look at example 3 where we're simplifying square roots of fractions. So we have two problems in example 3. Problem A gives us a radicand with 1/4 under it. Problem B gives us a radicand with 25 over 144 under it. Now, I don't know the square root of 1/4, but I can rewrite this as the square root of 1 over the square root of 4. Square root of the numerator over square root of the denominator. And I do know the square root of 1 is 1 and the square root of 4 is 2. So I've solved it by rewriting this problem as square root of the numerator over square root of the denominator, and then finding the perfect square of the numerator and the perfect square of the denominator. I can do the same thing with this next problem. Square root of 25 over 144. I don't know the square root of that, but I can rewrite it as square root of 25 over square root of 144. And I do know those. The square root of 25 is 5 and the square root of 144 is 12. And I have solved this problem as well. But now what happens if I have a fraction that maybe I don't know if it even has a perfect square root, like we see in example 4? So in example 4, it looks like the same type of problem, but I have square root of 180 over 5. Well, 5 doesn't have a perfect square root. I know that because I know that 2 times 2 makes 4, and then 3 times 3 makes 9. And 5 comes in between that 4 and that 9. So I know that 5 doesn't have a perfect square root. I'm not even sure about 180. So let's try this. Instead, let's do the division that we see represented right here. Let's say 180 divided by 5 and see what that turns out to be. Well, if I try that, 180 divided by 5, I get 36. And I do know the square root of 36. It's 6. So I can solve it by doing division underneath the grouping symbol of the radicand first. In example 4, we have problem B that looks like this. Square root of 219 over 3. Well, same thing. I don't know the square root of 219, and I know that 3 doesn't have a square root because 1 times 1 is 1, 2 times 2 is 4, 3 comes in between that 1 and that 4, so that means it doesn't have a perfect square root. So let me try to do the division. 219 divided by 3, well, that gives me 73. That's at least a little simpler, but I don't know the square root of 73 either. So if I use my calculator and I punch in square root of 73, I get this big old long hairy decimal that looks like it's never going to end. That just tells me that this problem is irrational. There is no square root of 73. This is as simplified as it can get, and it's irrational because it doesn't have a perfect square root. And then problem C in example 4, I see the square root of 12 over 75. Well, I'm pretty sure 12 and 75 don't have perfect square roots either, but I recognize that they do share a common factor. 12 and 75 both can be divided by 3 to kind of reduce to lowest terms. So if I divide 12 by 3, I get 4, and if I divide 75 by 3, I get 25. Well, now I know that 4 and 25 have perfect square roots, so now I can rewrite this just like I did these problems in example 3. I'm going to write square root of 4 over the square root of 25 because I know that's going to give me 2/5. And these two answers, actually all 4 of these answers here, are all rational because we simplified to a point where we had a number or several numbers that did have perfect square roots, and then we found those perfect square roots to make our answer. So those are all rational, where this one lone problem right here is irrational. because even though I simplified down to one number, that one number didn't have a perfect square root. So that created an irrational solution. Let's look at example 5, and then we'll be finished with this lesson. So for example 5, I have 3 times 5 over 12 plus square root of 128 over 242. Okay, now GIMDAS tells me I need to start with the grouping symbol. Okay, so in this problem, the grouping symbol is my radicand. So I need to start right here. Well, I don't know the square root of 128, and I don't know the square root of 242. I'm not going to try dividing it. It's not going to make a whole number because it's not an improper fraction. It's a proper fraction. So I will try reducing it to lowest terms. I know that 128 and 242 can both divide by 2. And when they do that, I get 64 and 121. Well, I recognize that both of these have perfect square roots. So I'm going to rewrite this problem as the square root of 64 over the square root of 121. The square root of 64 is 8, and the square root of 121 is 11. So now my problem looks like this: 3 times 5 over 12 plus 8 over 11. So now I'm ready to move to multiplication, which is what's indicated here. I'm going to put my 3 over a 1 and look for opportunities to cancel. 3 and 12 share 3 as a common factor. So I can cancel that. 3 divided by 3 is 1, and 12 divided by 3 is 4. When I multiply now, I have 5 over 4 plus 8 over 11. Well, now I'm ready to move to addition. But my rules for addition say that I need common denominators, and I don't have those. I'm going to rename these fractions as new fractions with a denominator of 44. I'm going to multiply this fraction times 11 to make 55 over 44, and I'm going to multiply this fraction by 4 to make 32 over 44. And now I can add these together, and I get 87 over 44. I need to rename this as a mixed number. 44 goes into 87 one time, almost goes in there twice. 88 over 44, I'd have just a 2. 87 over 44, I've got 43 left over. So I end up with 1 and 43 over 44 as my final answer. And then let's look at problem B for example 5. Problem B, I have 4 over 9 to the third power, not plus, divided by 8. So I need to start with my grouping and exponents. Here I've got 4 over 9 to the third power. Well, that means I need to say 4 times 4 times 4 over 9 times 9 times 9, and then I'll divide that by 8. 4 times 4 times 4 gives me 64. 9 times 9 times 9 gives me 729, and I'm going to divide by 8. Well, I need to put my 8 over a 1 and then do keep, change, flip. So I'll have 64 over 729 times 1 over 8. Now I'm looking for opportunities to cancel, and I see that 8 and 64 share 8 as a common factor. 8 divided by 8 is 1. 64 divided by 8 is 8. And now I'm ready to multiply my numerators, multiply my denominators, and I get 8 over 729 for my final answer. All right, our assignment for today's lesson is going to be 1 through 6 all. Then we're just going to do some select problems because these are multi-step problems that require several steps in order to come up with the answer, a little more time intensive. We're not going to do as many problems today as we normally do. We'll do 7, 11, and 14, and then we'll do 17, 20, and 24, 28, and 30. And then, of course, we'll do the cumulative review. Okay, so the problems that are in the cumulative review, and then we'll be finished with this lesson. Now, if this lesson gives you any trouble at all, remember that you can go to afterschoolhelp.com and you can practice working with rational expressions on afterschoolhelp.com. We'll probably also have a quiz in a day or so that will give us another opportunity to practice with rational expressions. And then, of course, we'll have our chapter review that we're supposed to do, I believe, on Thursday so that we're ready for a test on Monday.